Okay, Assalamualaikum. So today we proceed with the next topic, which is the Anova table and also the confidence interval. Okay, so usually you have learned before this in the previous chapter how to draw the analysis of variance table and also how to find the value of SST, SSR, also SSE, and how to find the confidence interval for the mean response for the parameters beta 0 and beta 1, and also the prediction interval. Okay, so before this, you have done before this using the formula to get all the value of SST, SSR, also the standard deviation. Can. So today, we focus on how to find all of that value that needed using the matrix approach. Okay, so from the previous lesson, you already know how to key in all the data in matrix form and use that to calculate the value of beta naught and beta 1 or to find the estimated regression function. Alright, so now we proceed with the Anova table. As you know, to create the Anova table, we need the SST, we need the value of SST, SSR, and also SSE. Okay, so as usual, this is the formula to get the SST that you already hafal before this, right? Summation of yi square minus summation of y, all of that square divided by n. Okay, in a matrix term, you know, you dah hafal juga this term, right? Y transpose multiply y, okay, which is the summation of yi square. Okay, so actually, using the matrix, okay, we can get the value of SST using this formula, which is y transpose y minus dengan y over n. And here adalah number of observation multiply y transpose, semua ni matrix y transpose multiply matrix J multiply matrix Y. Okay, so matrix J adalah the square matrix. This is the example. Okay, the square matrix that the element in it is all 1. Okay, so this part is also adalah summation of this one, summation of yi square divided by n. Okay, so according to the formula, SST adalah summation of yi square minus summation of yi square divided by n, right? So sama je, tapi in matrix notation, this is the formula. Once we have this value contohnya, ataupun we can find it using this. Okay, how about SSE? We know that SSE adalah sum of square, which is the summation of EI square, right? So if we have this value, ianya adalah SSE. Okay, using the matrix notation, this is the formula to get the SSE. Y transpose Y, which is the summation of yi square minus dengan B transpose multiply X transpose Y. You know that X transpose Y adalah summation of summation of X, summation of Y and summation of XY. Right? This summation of yi and summation of xi, yi, right? Okay, and then B transpose here adalah matrix of coefficient B. Okay, matrix B adalah B0, B1 because of, in our case, ianya adalah simple linear regression, so we have to parameter. So B transpose kat sini will be transpose of this matrix lah. Okay, So dia akan jadi B transpose kat sini adalah 2 by 1 multiply here is also 2 by 1 here is 1 by 2 matrix beta adalah matrix beta adalah 2 by 1 beta matrix B transpose will be 1 by 2. Okay, multiply dengan this matrix 2 by 1. So you akan dapat 1 by 1. So you summation of yi square minus dengan when you multiply these two matrix, you akan dapat a value. Okay, 1 by 1. Alright, and then this is a formula to find the SS, R, ataupun just simply once we have SST, when we have SSE, just SST minus dengan SS. Okay, this is an example. Okay, to get the Y transpose Y, which is the summation of YI square. This is the form, and you will get this summation of YI square. And this is the matrix of B transpose, which is here ni will be the value of beta naught. Here will be the value of beta 1, and then di sini will be summation of yi. Di sini adalah summation of xy. Then you will get this value, and then you will we will use this two value to subtract that. So you akan dapat the value of SSE. Okay, so macam biasalah untuk nak buat Anova table, we should have the degree of freedom. Kan, you already know how to find the degree of freedom, and lastly you will have the value of F statistic in order to test whether your our model is significant or not. We will use that. Okay, and then the next one is how to find the variance covariance matrix. Okay, so in this case, we need the variance covariance metric for beta. Okay, variance covariance metric for beta. Why? Because of we need the value of the variance of beta naught and variance of beta 1 to calculate the confidence interval for the parameter. Okay, so this is the illustration of the variance covariance matrix. Okay, this is a formula to get the variance covariance metric for beta. Okay, for beta. So in this case, untuk simple linear regression, we have two parameter beta 1 and beta naught. So because of that, the variance covariance metric will be 2 by 2. Okay, as I mentioned before this, kan, dia punya diagonal di sini. Diagonal here will be the value of a variance, and the value, the other value kat sini adalah value covariance between the two variable. But now kita punya variable adalah parameter lah, beta naught and beta 1. So there is a formula to find the variance covariance metric. This is a notation, but to estimate that, we will use this formula. Okay, so yang tadi sigma square kan, sigma square beta, sigma square here adalah value apa ni, variance of the model, which is the MSE. So when we want to estimate this variance, kita gunakan MSE. Then you know this value, this matrix of X transpose X kan. Okay, if we recall back, X transpose X matrix adalah N summation xi, matrix 2 by 2, right? Summation xi square. Okay, so the value of MSE multiply dengan bila transpose, you akan dapat 2 by 2. So lastly, you akan dapat 2 by 2 matrix lah, which is the diagonalnya, the diagonal here will be the variance for beta naught, the diagonal, the value here will be the variance for beta 1. These two value adalah covariance matrix, like here, covariance matrix of beta naught and beta 1. Okay, so apa yang kita nak adalah these two value. variance of beta naught and variance of beta 1 in order to find the confidence interval for the parameter. Let's see this. Okay, let's see here is the value of MSE that we can have from the Anova table. This is the matrix X transpose X inverse. We have the matrix X transpose X and we inverse the value, then you will get this matrix. Multiply this, you will get this. And then from here, we observe from here, we can see that this value adalah variance untuk beta naught, this value adalah variance untuk beta 1. We need to use the standard deviation untuk nak cari confidence interval for the parameter. So you need to square root this value nanti. Okay. Alright. So just remind you, nak cari confidence interval for parameter, it will be beta I, which is sama ada beta naught or beta 1, the table alpha over 2, degree of freedom, and minus 2 multiply dengan standard deviation of the beta I. So we need this value of standard deviation for beta in order to find the confidence interval. And as usual, you can interpret the confidence interval. Okay, the next one adalah the mean response. Okay, the mean response also we need the standard deviation for the mean response. So first of all, you need to know how to find the value of the mean response. Okay, so before this, it is beta naught plus beta 1 XH kan untuk dapatkan estimated of the mean response. So kalau gunakan matrix notation, this is the formula. So which X transpose H adalah this value. Okay, this value which is 1 by 2. Okay, actually this is the matrix of XH 2 by 1. Bila you transpose, dia akan jadi 1 by 2. So di sini 1 by 2 multiply matrix of beta tadi adalah 2 by 1. Right? So you akan dapat satu value of Y hat. Nanti satu value kan. Untuk kira confidence interval for the mean response. Next, we need the standard deviation of the mean response. This is the formula to get the variance. Then you need to square root this value. Okay, so if you can see the formula, it is MSE multiply X H transpose multiply X transpose X inverse multiply X H. Okay, this is all the value. X H and X transpose. And then apply in this formula. So let's see the example. Let's see our independent variable adalah 65 that we need to replace in the matrix here. Okay, so this will be the formula. Sebab ada dua lah sebenarnya. Ni satu lagi tadi. Okay, sama ada you gunakan MSE di sini, multiply di sini tengahnya X transpose X inverse, ataupun you just if you have the matrix of the variance covariance, you can use this. Using this formula, you can have the value of the variance of the mean response. Okay. Here we call back to get the confidence interval of the mean response. It is the standard deviation of I hash. Okay, then interpret like usual. Okay, the next one adalah the prediction. Okay, seakan sama, cuma ditambah yang ni sahaja. Okay, 1 plus here. Itu sahaja bezanya. Okay, so kalau as prediction, it is Y H, dia sama je kan, iaitu plus minus T alpha over 2 in minus 2 and then S prediction. Okay, S prediction. Okay, so you need to square root this value. Okay, Right, so that's it. Simple saja. If we can see this, for example, here this is um the data, ada 25 data altogether, agak panjang. So if we want to express it using the matrix terms, it will be like this, the y kan, and then the x will be this, really, n by 2, and then when we transpose, we'll get that. Bila kita multiply x transpose dan multiply x, we akan dapat this. Just replace all the value that we can calculate using the calculator, this value x squared, so we can get this x transpose x matrix. And then untuk x transpose y, this is the matrix yang dah hafal before this. So this is the matrix yang you akan dapat. So bila inverse, tak perlu buat macam ni, tak apa, using calculator, lastly you will get this inverse matrix of x transpose x. All of this nanti you akan gunakan untuk nak cari beta naught and beta 1 using this formula. So we have here beta naught and beta 1, and then we also can express the matrix of y hat, which is the estimator of y hat using this formula. Ini matrix x, ini matrix beta. Bila you multiply these two, saya akan dapat bentuk macam ni. So this column ni adalah value of y hat, y1, y2 until y25, y hat 25. Okay, untuk dapatkan E matrix, you know that it is y minus y hat adalah x beta, this x, this beta. So last kali, you akan dapat this lah, ini matrix y, ini value ya data yang asal y, minus dengan y hat, which is the matrix x, multiply dengan matrix beta. Last kali, you akan dapat this value. Ini adalah list of your residual pertama sehingga residual ke 25. In order to find the Anova table, we need the value of SST, and then we know that y transpose y adalah summation of yi squared, that we can get it from the calculator. And then we know that this value adalah summation of yi square divided by n. So you get this value. Lastly, you can get the value of SST. Okay, next to find the SST, which is the summation of yi square here, y transpose y multiply this value. So usually yang ni lah, this value yang you need to multiply. Okay, it means the value of beta naught and beta 1 is the summation of y, summation of xy. Then you will get this value, and then minus this 2, you akan dapat SSE. Okay, and simply just minus SST minus SSE untuk dapatkan SSR. Okay, so and then if we need to calculate the value of variance covariance for the beta, MSE multiply dengan x transpose x inverse using this formula. Okay, so replace here, and then you will get this value yang you akan gunakan kat sini adalah these two value. Okay, ini adalah variance for beta naught, ini adalah variance for beta 1. We need this two value untuk nak cari confidence interval nanti. Okay, this is the way how to find the y hat. Okay, you need to create this values, this matrix first, matrix x transpose h, which is 1 and 65, and then letakkan value matrix beta, so you akan dapat y hat untuk x 65. And then you need to calculate the value of the variance for the mean response here using this formula, since we have the variance covariance matrix tadi. Okay, dapatlah value tu, bolehlah kira confidence interval for the mean response. Let's say we want to find the confidence interval for the prediction value 100 x hash 100. So sama untuk dapatkan y hat, this is a formula sama macam tadi juga, cuma nak cari variance of prediction sahaja berbeza kat sini. Okay, MSE, this is the XH, the X transpose X inverse. Yeah, so this is the value of S square prediction. So that is the way how you calculate all the value and use it to to find the value of confidence interval dan juga Anova table. Okay.